Hello and welcome to this video. In this video, we're going to solve the problem first factorial. So this is an algorithm that is basically easy for a beginner. So this is level 1. In the next videos, hopefully we're going to increase the step by step the level. But for this moment, we're just going to go with an easy level. So let's try to understand what is the problem and try to solve it. So have the function first factorial that takes a number as an input. We need to basically compute the factorial of n. So the factorial of 4, for example, is 4 times 3 times 2 times 1, which is 24. So basically, if we have an input n, the factorial of n, factorial of n equals n times n minus 1 times n minus 2, and yeah, we continue till times 2 times 1, and with the condition that factorial of course 1 is 1, and also the factorial of 0 is always 1. This is the conditions. This is preconditions. So basically, if we see this sentence, factorial of n is n times this. So what is this? What is n minus 1 times n minus 2 till 1? It's basically factorial of n minus 1. So we can basically say factorial of n equals n times factorial of n minus 1. So we could basically write factorial of n in function of factorial of n minus 1, which is what we call recursivity. So if in order to compute function of n, we need to calculate function of n minus 1. So this is one solution that I'm going to write the solution for using recursivity. And I'm going to also use another method, which is basically using a simple loop to do the same, to basically come up with the solution for the same problem. So let's just see first, what is recursivity? What we said, if an input is n, we need to see if n equals 1 or n equals 0, what do we do in this case? We just return 1. We know that if n is 1 or n is 0, the solution is 1 all the time, no matter. Otherwise, we need to return what? N times recursively call the same function, factorial, first factorial, we call it first factorial in this problem, n minus 1. That's it. So in order to compute this, we need to return this, which calls basically the same function with n minus 1. So let's see, for example, if we call it with 4, it gets 24 as expected. If we give 8, we expect this number as an output. So let's just see. Voilà. It works perfectly. So this is what we call recursivity. So a function calls itself. And let's explain to you a little bit how it works. So imagine that we give 3 as an input. So we call factorial of n, we go n equal 3. N is not 1 and is not 0, so we cannot go here. We need to go here. So we go here and n is 3, so 3 times factorial of 3 minus 1, which is factorial of 2. So now we need to compute factorial of 2. What is factorial of 2? N equal 2. So 2 is different from 1 and 0. We cannot go here, we go here. So 2 times factorial of 2 minus 1, which is 1. And factorial of 1 is n is equals 1. So we come here Is n equals 1 or 0? Yes, n equals 1 because n is 1. So we need to go here, we return 0 and we are finished. Do you see how Factorial works? It's basically, this is the logic. The function calls itself. So what about if we try to do another solution, but using a loop? So what are we gonna do? We're gonna do a loop that starts from an I from n, and we need to keep looping while I is bigger or equal to 1. And every time we need to do I minus 1 after every loop. So, and we need to have something called result that we initialize by 1. And every time we do result equals result time I. But this is not a good syntax, of course. We need to we prefer to do this syntax. So just for a better syntax. So every time we go into the loop, I starts from n, and we keep decreasing I till we reach 1. And every time we multiply I by result, and we give results the new value. And at the end, we need to return result. So factorial of 3 is 6 because 3 times 2 times 1 is 6. Factorial of 4 is 24. And factorial of 8 should be this number. It's correct. So this is the solution with just a simple loop. And I forgot a let here. Sorry for that. Yeah. So thank you guys for watching this video. If you did like the content of this, please give it a thumbs up and consider subscribing for more videos in the future. Thank you so much and wish you a good day. Bye-bye.